Hello students, welcome to Learner's Planet, theory session 9 of periodic classification of elements. Now students, this will be our last session of our topic, periodic classification of elements. Now I hope you have understood the periodic table, about the elements and also about their properties. So students, this is a very important topic, and in your 11th we will be discussing it in more details. So now in my last session I discussed about the metallic character, the electropositivity as well as electronegativity along the group. Now in this session I would be discussing about the chemical reactivity along the group. So now let's start students. Here it is the chemical reactivity of the elements. While going down in groups 1A, 2A and 3A, the chemical reactivity of elements increases. In the periodic table among group 1A elements, the order of reactivity of elements is francium greater than cesium, greater than rubidium, then more than potassium, more than sodium and more than lithium. I told you the reason in that. Say these elements, how they react? They react by forming a positive ion. Say if lithium has to react, what it will do? It will form a positive ion and it will form what? And it will give an electron. If cesium has to react, what it will do? It will again lose one electron and form a positive ion, that is cesium plus of an electron. Now what I told you students was that when we move from top to bottom in a group, what is happening? The electropositivity is increasing. Why electropositivity is increasing? Because the effective nuclear charge or the force of attraction of nucleus on the outermost electrons is decreasing. Okay, now let's see the reason behind this. As we move down the group in the periodic table, the size of atom of elements increases. Why? Due to the increase in number of shells of electrons. This we have discussed. Now, as the result of which the effective nuclear charge, that is the net force of attraction on the valence electrons, on the valence shell electron decreases because of more distance. I'll just draw it here. Say this is your lithium and this is your cesium, a very big atom. Okay, so the center is your nucleus, and this nucleus is exerting force of attraction on the outermost electron. So this is your lithium and this is your cesium. You can just guess what is happening. The size is increasing and so the force of attraction will be decreasing. So the tendency to lose electrons from valence shell increases, and hence the chemical reactivity of elements increase. That is, the tendency to lose electrons, that is this electron has to be lost. Here this electron has to be lost. Which will be lost faster? Cesium. Why? Because the force of attraction is less in cesium and it is very high in lithium. So what will happen? It will lose its electron easily, form an electropositive ion and will become more reactive. Say, this is the chemical reactivity of group 1A elements. Lithium, sodium, potassium, rubidium, cesium and francium. Which is least electronegative? Lithium. And then the most electronegative here is francium or the cesium. Francium. Okay? That is the chemical reactivity is increasing down the group. Now what about the chemical reactivity of non-metals? How these non-metals react, students? Non-metals react by forming a negative ion. Okay, so this is forming what? This is forming F minus ion. Likewise, your astatine or iodine, I can say, what happens to iodine? Iodine is also accepting an electron and is forming what? It is forming I minus ion. Now I told you again about the size of fluorine. So size of fluorine is very small. And what about the size of iodine? Size of iodine is big. What about the nuclear force of attraction on the incoming electron? It would be maximum in fluorine and it would be less in iodine. Okay, so this electron is coming inside. So, which will form a negative ion earlier or faster? Fluorine. And whereas iodine will form the slowest one. Okay, so in the table, periodic table, group 7A elements, the order or reactivity of elements is fluorine greater than chlorine greater than bromine and then iodine and then astatine. So in general also students, in all the groups, what happens? The reactivity, the chemical reactivity decreases down the group. So keep this thing in mind. Now the reason behind this, as we move down the group in the periodic table, the size of atom of elements increases. Why? Due to the increase in number of shells, as the result of which the nuclear force of attraction on the incoming electrons decrease. Okay? So, the tendency to gain electrons decreases, due to which their chemical reactivity also decreases. This is the chemical reactivity of group 7A elements. So fluorine, most reactive. Astatine, least reactive. Now let's take up the next property, that is the gradation of physical properties of the elements down the group. What happens? While going down in a group of metals, physical properties such as melting point, boiling point decreases gradually. I have shown you here in the table here, that is the lithium, the melting point is 180, the boiling point is 1347 degrees centigrade. But if we see of potassium, it is 63 degrees centigrade and 774 degrees centigrade. Now let's check out why it decreases. Say the boiling point. Okay, the boiling point, or let's check out the melting points or the boiling points. It's the same thing. It's not the same thing, it's a different thing. Points or the melting points. Okay, now students, these all depend on the type of force of attraction between them. Okay, say, let's talk of water. I can explain you very well with the help of water molecule. Say, if I have taken a container, I hope I have given this example to you before also. Say, if I am taking some container here and I am putting in, let's see, anything that is molten. Let's talk of the metals only. Now I'm putting in here the molten sodium. Okay, and I am taking another container and I am putting here the molten potassium. Okay, though the reaction will be very explosive types, but in order to explain you, I am taking this example. Okay, students, now I just want to boil it. That is, I want to change this metal into its vapor state. Great. Now you can find out here what is the boiling point of sodium. It is 883 and potassium is 774. Okay, it is 883 degrees centigrade and it is 774 degrees centigrade. Now why is it so? Now again come to the size of atom. Say size of sodium is this. Okay, but the size of potassium is bigger than sodium. Okay, now what is happening? The type of force of attraction between the two. The type of force of attraction between the two would be the metallic force of attraction also, and there are certain forces that is called as van der Waals forces of attraction. And this van der Waals forces of attraction is inversely proportional to the surface area. Now, the more is the surface area, it is directly proportional to the surface area. Sorry, here. It is directly proportional to the surface area. Okay. So, more is the surface area, more will be the force. So, that is the force with which these two atoms of sodium will be bonded is what? So what is happening here? Now this force is what, students? This force is the force between, that is van der Waals force of attraction, is the force between this nucleus and the electrons of other atom, as well as the nucleus and the electrons of this atom. So this is what? This type of force is called as van der Waals force of attraction. Now in this case, again, this is the force of attraction between this nucleus and this electron. Whereas again, there is force of attraction between this nucleus and this electron. So what happens? The farther is the electron, the less will be the force. Now in this case, say this nucleus, it is far away from the valence shell because the distance is more. Here the nucleus and the outermost distance is more. Whereas in this case, the nucleus and the outermost distance is less. So in which case the van der Waals forces of attraction will be more? The van der Waals forces of attraction will be more in case of sodium. Okay, so if I'll not give this concept of surface area, then also it's okay. So what I'll write here is that in case of sodium, the van der Waals forces of attraction is more. Okay. So in case of sodium, this force of attraction is more than that of force of attraction. What? Van der Waals forces, right? So in case of sodium, it is more. So in which case the atoms will be strongly bonded? It will be strongly bonded in case of sodium. So which will require higher temperature to go into vapor state? Sodium. Whereas potassium will require less. Okay. Likewise, it depends on the size. That is, what is this type? What is this van der Waals forces? I hope you got this. Just I'll revise this. That van der Waals forces of attraction is the force between nucleus of one atom and electrons of the other. Now, as the size increases, what happens? That the nucleus becomes more embedded. It comes more inside. So, the force exerted by it on the electrons becomes less. So, it can easily go into the vapor state. Okay. Likewise, if I talk about the melting points. Okay. Say, I'm talking about the melting point. So, what is the melting point here? It is the temperature at which solids start melting, or they start changing into their liquid state. Okay, so in this case, students, what are these? This is sodium is a metal, and again potassium is a metal. But what is happening? Again, there is some force of attraction between the two. Right. So there is some force of attraction, that is, these have got these are present, there is a force of attraction here. But potassium is again bigger in size. So in which case the force of attraction between their the nucleus, or the force of attraction between their atoms will be more. It will be obviously more in sodium and less in potassium. They both have crystalline structure. Why? Because they are metals. So again, the force of attraction between the two atoms is more in case of sodium, whereas it is less in case of potassium. Okay, so which will have a higher melting point? Sodium. Now that's what is said here, that the melting and the boiling point decreases gradually. I hope you understood this concept. This only depends on the force of attraction between the atoms or the molecules. The more is the size, the less force of attraction is between them. The less is the size, the more force of attraction. The more is the size, the less force of attraction. And in crystals also it's like that. While going down a group of non-metals, the physical properties such as state, melting point and boiling point increases gradually. Now in this case, why it increases? Say I am taking a group of non-metals like nitrogen, phosphorus, arsenic, antimony and bismuth. Now in this case, students, what happens? There is a gradual transition from non-metal, then there is a metalloid, then there is a metal. Okay, so there is a gradual transition here. Now this is a metal, so it will have a crystal structure. Whereas this is a non-metal, it will have a gaseous form. So which will have a more melting point, a solid or a gas? Obviously a solid. So likewise the boiling point also happens like that. Okay, because there is a transition from non-metal to metal. So student, everywhere you can't apply that concept that size is increasing, so the melting and boiling point would be decreasing. In case of non-metal side, that is a group of non-metals, there is a gradual transition from non-metal to metal. And always remember one thing, what? that metals have a higher melting points or boiling points, than non-metals. So what is happening to the melting and the boiling points in non-metallic groups? The melting points and the boiling points of the elements increase gradually. Like group 7A, fluorine, it is a gas. Its melting point is minus 220 degrees centigrade. Boiling point is again minus. Likewise, maximum is of iodine, which is a solid. So solids obviously have higher melting points and higher boiling points. I hope you are getting these concepts, students. Now in this case, there is another property, that is nature of oxides. Now what happens to this? On going down in the group of the periodic table, there is no change in the nature of oxides. The nature of oxides of all the elements of the group is the same. Let's write the elements of the group first. Say lithium, sodium, potassium, rubidium. I'll write till here only. I hope you know the rest of the elements. Beryllium, magnesium, calcium, strontium, boron, aluminium, gallium, indium, carbon, silicon, germanium, tin. Likewise, your nitrogen, phosphorus, arsenic, antimony. Now what is happening here? This will form a basic oxide because it is a metal. This will again form a basic oxide because it is a metal. Whereas in this case, this is forming what? This is forming an amphoteric oxide. This is also an amphoteric oxide and a basic oxide. Here these are forming acidic oxides. Carbon dioxide is acidic. Si is acidic. The acidic nature of the oxides is decreasing down the group. Okay. Here again the acidic nature of the oxides is decreasing down the group. Right. So what is happening? The nature doesn't change. Non-metals form acidic oxides and neutral oxides, whereas metals form basic oxides and amphoteric oxides. So at any point of time, you just remember that whether the metal is an acidic or it is basic. Whether a given substance is metal or a non-metal. Non-metal will form what? Acidic oxide. Whereas metal will form what? Basic oxide. So we can write here that the nature of oxides of the elements depends on its metallic nature. On its metallic character. On its metallic or non-metallic character. Okay, say if it's a non-metal, your nitrogen is a non-metal, it will form acidic oxide. Nitrogen, phosphorus, arsenic, antimony, bismuth, it will form a basic oxide because it is a metal. Okay, so metals, they form what? Basic oxide. They have they do not actually depend on the position in their group. Okay, so there is a change depending on the nature of their oxides. Okay, so there is a change in the nature of the oxides. Like your boron, it forms acidic oxide, whereas aluminium is forming amphoteric oxide. Your lead is also forming carbon, silicon, germanium, tin, lead. Lead is forming an amphoteric oxide. Okay, whereas your silicon is forming acidic oxide. So this is nitrogen, your silicon, acidic. So first of all, what you have to do is you have to, for finding out the nature of oxides, what is required is you need to predict whether the element is a non-metal or a metal. Okay? So if it is a metal, it will form basic oxide, and on the non-metal side, it will form an acidic as well as the amphoteric based on whether it is a metal or a non-metal. Like in your fluorine group. Fluorine, chlorine, bromine, iodine, all will form acidic oxides. Okay, these all are forming acidic. Though their acidity decreases, say the most acidic oxide will be fluorine, then there will be chlorine, Cl2O5 or ClO2, and least would be iodine. Right? So students, this is all about your topic of periodic classification of elements. I hope you understood this topic. Now we will be meeting for the problem solving session of this topic. So thank you very much for your patience, and I hope you'll practice and you'll read this topic, and I hope I was able to make this topic interesting for you.